Hi, we are looking at section 2.4, which is titled Buy, Rent, or Lease. This section essentially looks at the same stuff as we've been looking at the entire chapter, but more focused on housing type finance questions. So we're going to introduce some more vocabulary, and then we'll look at some example questions. So some definitions: a lease is a contract purchasing the use of a property, such as a building or property, for a defined period of time. So you do not own the property with a lease. You are just essentially spending money for the right to use it for a set period of time. Now, equity is a portion of an object that has been paid for. So for example, if you're buying a house and paying a mortgage, your mortgage payments go into paying off some of the interest, but they also go into paying off some of the value of a house, in which case your equity is gaining values. An asset is an owned item of value, so property, vehicles, art, things like that. We also have appreciation, which is the increase in the value of an asset over time. Depreciation is the decrease in the value of asset over time. We also have what's known as disposable income. So that's income that is available for spending once regular expenses are deducted. So regular expenses would be things like housing, utilities, transportation, the essential things that you need to spend your money on. Okay, so first example, we look at transportation. You're looking for a new vehicle and have two options to choose from. You can lease a vehicle for 4 years with a down payment of $4,000 and monthly payments of $380. You buy a vehicle for $32,800 and finance it for 4 years with an interest rate of 4.5% compounded annually, paid monthly. What is the better option? Okay, so I'm going to call this first one option A, this one's option B. So we'll calculate each one on its own. Now for lease, calculating how much we're paying is fairly straightforward. It is essentially just our number of payments times how much those payments are. So we want to lease it for 4 years with monthly down payments. So that gives us 4 times 12 times the amount we're paying per year, and then we'll add on the down payment. And we find that for 4 years, it costs us $22,240. Part B, we're going to need the TVM solver to solve for, because we're making regular payments and we need to find out how much we actually end up paying. So I'll write out the categories that we'll be putting in our TVM solver. Okay, so we want to finance a vehicle for 4 years with monthly payments. So our N is going to be 4 times 12, so 48. Our interest rate we're given is 4.5%. Our present value is how much we're going to owe on it at the start, so negative $32,800. our payments are what we're going to solve for. Future value is going to be 0. Our payments per year is 12, and it's compounded annually. So our compounding periods per year is 1. So we'll put this in our TVM solver. So once again, that's apps, finance, TVM solver. So I've got N is 48, I is 4.5, PV is negative 32,800. Payment we're solving for, future value 0, payments per year is 12, compounding periods per year is 1. We'll leave the app, reopen it as solving for our payments. And we get our payments are $747 and 95 cents. So if this would be our monthly payments, I'll need to figure out how much we pay in total. So our total paid it's just going to equal our amount of payments, which we know is 48, times the amount that we're paying each month. So $747.95. So that gives us $35,901.81. So looking at this, clearly option A is our cheaper option over the 4 years. But what we have to take into account is at the end of 4 years, the vehicle that's leased goes back to the dealership and we get nothing back. So we have spent this amount, which is cheaper than what we spent here. But with this one where we spend more, we still have an asset. We still have the vehicle at the end. Now, depending on some factors, this may still work out better, but we'll look at that in another example. So for example, if a car in the previous example depreciates at a rate of 15% per year, and you take the asset value of a car into account at the end of 4 years, which is a better deal? So what we'll do is we'll use our compound interest formula to figure out what the value of the car is after the first 4 years. So our compound interest formula is A is equal to P times 1 plus I over N to the power of NT. So we're looking at for what it's going to be worth. So we've got A is equal to our initial amount, so $32,800 times 1 Now, typically we'd have plus our interest, but because it's depreciating, we're actually going to subtract. So minus 0.15, and our compounding period is just going to be 1 to the power of 1 times our amount of years, which is 4. So at the end of the 4 years, the vehicle is worth $17,121.81. Now, if we look at our overall cost, if we consider that we still have an asset that's worth this amount, what we can do is we can take the amount we paid and subtract the asset value. So we paid $35,901.81. And we still have an asset that's worth $17,121.81. So if we take into account our asset that we've gained, it ended up costing us $18,780, which then ends up being actually better than the leasing, because we now have this asset, this car that we can continue driving after the 4 years. Now, if we had a higher depreciation rate, this value that we had for costs might be higher than the lease, in which case it'd make more sense to lease the vehicle. Next example, two people made different decisions about whether to rent or buy a house. The first bought a house for $349,900. They're paying a down payment of 5% and are using a mortgage to pay the rest. The mortgage is compounded semi-annually at 6.5% and paid monthly. It has a 20-year term. The second person rents a house for $2,000 a month. If after 5 years, both people decide to move and the first person finds that their house has appreciated by 5%, compare each person's situation after those 5 years. We'll just call this one A, this one B. So look at person A first. So first thing we need to do is figure out what values are going to go into our TVM solver. So we might as well write out the categories, then figure out what's going in each section. So we have N, we have I, PV, PMT, FV, PY, C/Y, and payment end. Okay, so N is simply going to be our number of payments. We're making monthly payments for 20 years. So 12 months a year times 20 years gives us an N value of 240. We're given an annual rate of 6.5%. And our present value is not actually going to be $349,900 because essentially we have to pay a down payment of 5%. So we have to pay for 5% of the house up front. So to figure out what our present value is going to be, we will take our house price of $349,900 and subtract 5% of that. Now, to calculate 5% of that, we're just going to go 0.05, which is 5% as a decimal, and multiply it by $349,900. And that gives us a present value of $332,405. So PV is going to be negative $332,405. We're going to be solving for our payment. Our future value after 20 years is going to be 0. Payments per year is 12. Compounding periods per year is also 12. So what we're going to do now is solve for a payment. So our payment with our TVM solver ends up being $2,478.32. Now, because they're moving after 5 years, we need to find out how much they still owe on the house after 5 years. So we're going to enter our information into our TVM solver again. However, our N, because we're just going for 12 years, is going to be 12 times 5. So our N is going to be 60. Our interest rate will be the same at 6.5. Present value will be the same at negative $332,405. Our payments we just calculated, so they're $2,478.32. Future value is what we're going to be solving for. Payments per year is 12. Compounding periods per year is also 12. Now, when we put in our TVM solver, that gives us a future value of $284,000. Or sorry, $284,502.69. So this is how much we are still owing. Now, to figure out how much profit we've made on a house, because we're now selling it after owning it for 5 years and it's appreciated, and hopefully more than the amount of interest that we're paying, what we actually want to do is figure out the new value because it's appreciated by 5%. So that's just going to equal our original amount of $349,900 times 1.05. Now, for the reason it's 1.05 is we essentially have 100% of our original house value, and we're adding the extra 5%. So that's going to be 105%, which as a decimal is 1.05. Now, if we depreciated, I would have subtracted this percentage. So that gives us $367,395. So this is its new value that we're able to sell it for. So to find out what we end up with, what we can do is take the new value and subtract how much we still had owing. So we'll just call that profit. So that's going to be $367,395 minus $284,502.69. And that tells us that we brought in $82,892.31. So that's how much we got. However, that's not complete gain because we did end up paying mortgage for 5 years. So if we want to find out how much it actually cost us for those 5 years, we have to look at how much we have paid in and how much we've now gained in equity. So we're going to have to look at how much our down payment was. Add onto that our monthly payments. And we'll subtract this profit. So our cost is essentially going to be our down payment, which was 0.05 times 349,900 plus our monthly payments. So we had 5 years, so we had 60 payments times $2,478.32 minus this profit, so $82,892.31. So it actually ended up costing us $83,301.81. Now, if we look at cost of person B, our calculations are just going to be a lot simpler because their cost is simply going to be the amount of months times amount of years times their rent, which was $2,000. Which is $120,000. So you can see that the person who bought their house, essentially it costs from $83,301.81 to live there for 5 years when you take into effect the equity they are able to gain in reselling the house, while person B did not gain any equity and purely has their cost, which is $120,000. So person who bought the house ended up better off economically by about $37,000.